Okay, so just another quick one to add to the other one because I missed a whole bit and it's a whole part of the study design. So factors that can affect our battery life, our battery usage, why we would use them, how we would use them. And this is a really good one when we think about some of the questions they might ask you. So they might ask you about other planets. They might ask you about using it in Central Australia compared to using it in England. Like, there would be different considerations for different places that we need to think about batteries and fuel cells and equilibrium and all that kind of thing. So generally, when we're increasing the temperature, we're going to be increasing the rate of reaction. So that means when we're looking at our batteries, we're increasing the rate that things are being used up. So if we get really high temperatures, it means that battery life, the reactants get used up quicker. So they're getting used up quicker. We've got an increased rate. So we end up kind of getting a lower battery life. And we're not going to use more energy. We're not necessarily using more on my laptop when it's a hot day than when it's a cold day. So that increased turnover is not really beneficial to me. So it means my battery doesn't last as long in a really hot day than maybe on a cold day. I don't know what the temperature for with these ACEs is probably terrible. So if I was going somewhere really, really, really hot, really, like if I was on Mars and I was, in that sunlight in my spacesuit working on my computer and it was getting really, really, really hot, I'd have to consider maybe using a different type of battery or something to shelter my battery, keep it insulated so it didn't have that really high turnover and use up all my electricity. Also, when the energy gets really low, so I'm also on Mars and it gets to nighttime where it gets really, really cold because of the lack of atmosphere, I get a really, really, really slow rate of reaction, which probably isn't going to be very useful for my producing my products that I need to make my battery work. Also, what can happen is we can have an expansion. So think of, when things get cold, they can expand and pop. Also, when it's hot, I suppose, we can get in extremes of temperature, they expand, things are going to break, snap, dislodge, that puffing. I'm sure there's, people who leave laptops and things in cars and they puff up, battery explodes. There's that high temperature, but it can also happen with really low temperature. So there's this water in here, water expands when it freezes. If it gets really, really cold, it's going to pop, and that's it. The connecting things in your battery are going to work. So you've got that kind of a change in temperature. Other factors that can affect our battery life. So if we have side reactions happening, so we looked at the reactions, it's very simple, but really that's not what's going to happen. We've got, maybe zinc in there, we've got other coatings, other things in there that help with the life. That might lead to other side reactions. This is the main reaction, but there might be side reactions. The side reactions might form inactive reactants or products that we can't use anymore. So they kind of get stuck over here, away from our main reaction. If we think about our reaction happening here, and they can't kind of get back in our cycle, so they just kind of get stuck there. And if we get too much, that's going to really limit our amount of reactions that are happening. You might have some reactants and products detaching from my cathode and anode. So when we have that build-up happening around them, they might detach before I need them to, before I start using them up. And they might sit at the bottom and not get used up. So they might just sit there and not be used in my reaction. So then they're just bystander spectators and they've been used up and they're not going to be revolved anymore. We might have corrosion. So inability to use, we get these crystals happening, things break down, the connections can't be made properly anymore. And leakage. So leakage of, the batteries split. Stuff comes out and you can't use them anymore. Generally they're acidic, as we saw from our thing. There's lots of, can be acidic or basic, and those can get involved. We get this corrosion and this breaking down of the metal and these kind of crystals, and then that means they're not going to use. So those are things that can affect my usage of my batteries. Again, another thing we need to know in the study design that just feels a bit whacked in there for no. But think about reaction rates. Think about when we have reactions. That's kind of what you need to understand in there, I think, is their thinking.